Dear students, Assalamu alaikum. Our lesson is about the preparation of a solution by dilution. At the end of this video, you will be able to describe how to prepare experimentally solutions having different concentrations starting from a standard one. Please prepare your pen and your chemistry booklet. Now, let's read together the steps that must be followed to prepare this solution. Step number 1, pour in a clean beaker some of the initial solution to avoid any contamination. Contamination means making something impure or unsuitable. Step number 2, take the volume V using a volumetric pipette equipped with a pipette filler. This is the volumetric pipette and this is the pipette filler. Step number 3, introduce the taken volume V in a volumetric flask of volume V prime. Step number 4, add distilled water till the half of the flask and shake. Step number 5, add distilled water with precaution till the line mark. This is the line mark. Step number 6, close the flask and shake well to homogenize. Don't forget that the color of the standard solution is more intense, darker than that of the dilute solution. Okay, let's take a look about the difference between a volumetric pipette and a graduated pipette. A graduated pipette is a glass instrument used to transfer different measured amounts, for example 11, 16.6 milliliter, etc., of liquid material from container to another, while the volumetric pipette is a glass instrument used to transfer a specific measured amount from one container to another, and it's more accurate than the graduated pipette. You can observe here the different volumes in the graduated pipette. While in the volumetric pipette, the line mark indicates one volume, such as in this figure 10 milliliter. So the line mark shows a specific volume, one volume. So with a graduated pipette 20 milliliter, we can take 10, 11, 18, 19, 20 milliliter different volumes. While with a volumetric pipette 20 milliliter, we can take only 20 milliliter, one volume from the standard solution. Okay, it's time to do some applications. Application number 1, describe how can we prepare 100 milliliter of a KNO3 solution of concentration 0.045 mol per liter, starting from a solution of concentration 0.25 mol per liter. You have to show the necessary calculation and the procedure. First of all, let's write the given to make the calculation. This is an important step to solve the exercise. The standard solution S of molar concentration C 0.25 mol per liter. We use this solution to obtain a new solution S prime of molar concentration C prime 0.045 mol per liter, less than the initial one. And the volume that must be taken is represented by V, and it has to be calculated, while the volume of the new solution V prime 100 milliliter, because we have to prepare 100 milliliter solution. The calculation, we have to start with the conservation of the number of mole of the solute during dilution. Number of mole of solute before dilution is equal to the number of mole of solute after dilution. Using the relation of the molar concentration, write instead of N, C times V of the solution before dilution and C prime times V prime instead of the number of mole of solute after dilution. This implies that V, the volume that must be taken from S, equal to C prime times V prime over C. It's equal to 0.045 times 100 times 10 minus 3. Here we make the volume in liter. From milliliter to liter, we have to multiply by 10 exponent negative 3. We have to multiply by 10 exponent negative 3. Okay, over 0.25, the value is 0.018 liter. At the same time, it is equal to 18 milliliter. This indicates that we have to use a graduated pipette 20 milliliter. The procedure. Pour in a clean beaker some of the initial solution to avoid any contamination. Take the volume V 18 ml, this is the calculated volume, using a graduated pipette 20 ml equipped with a pipette filler. Introduce the taken volume V in a volumetric flask of volume V prime 100 ml. Add distilled water till the half of the flask and shake. Add distilled water with precaution till the line mark. Close the flask well to homogenize. Don't forget to memorize the procedure and pay attention that the volume changes with the exercises. As the calculated volume changes, so the graduated pipette changes its capacity and also the volume of the volumetric flask. Application 2. A solution of concentration C equals 0.02 mole per liter is diluted 5 times. Calculate the concentration of the dilute solution. Number of mole of the solute before dilution equal number of mole of solute after dilution. Using the relation of the molar concentration, C times V equals C prime times V prime. Then make the ratio C over C prime equal V prime over V equal F. This is the dilution factor. In this application, the fault is 5 times because the initial solution has been diluted 5 times. Therefore, F equals C over C prime, and then C prime equals C over F equals 0.02 over 5 equals 0.004 mole per liter. Evaluation time. It's required to prepare 100 ml of a solution S of concentration 0.1 mole per liter from an initial solution S0 of CaCl2 of concentration C0 equal 2 mole per liter. Available glassware, beakers, graduated pipettes, graduated cylinders, volumetric flask, volumetric pipettes of different capacities. Question number 1. Choose from the above list the convenient glassware with the appropriate volume to prepare with the highest precision the solution S. Justify. Take into consideration that one withdrawal from the initial solution is allowed and you have to show the necessary calculation. Second, determine the dilution factor, the fault, and then describe the experimental procedure of the above preparation. Dear students, pause the video to solve this exercise. Answers. Choose from the above list the convenient glassware and justify. The preparation of 100 ml of a solution leads us to use a volumetric flask 100 ml. And to avoid any contamination, we use a beaker 50 ml to pour some of the initial solution. Calculation. Number of mole of solute before dilution equal to the number of mole of solute after dilution. C0 times V0 equals C times V. Then V0 equals C times V over C0. V0 is the volume that must be taken from S. Okay, V0 equals 0.1 times 100 times 10 minus 3 over 2 equal 5 times 10 minus 3 liter equal 5 milliliter. And since a volumetric pipette 5 milliliter is available, we use it to take 5 milliliter from the initial solution. So the materials are volumetric flask 100 milliliter, beaker 50 milliliter, and a volumetric pipette 5 milliliter. Second, determine the dilution factor. The same relation must be used. C0 times V0 equals C times V. Then we have to make the ratios. C0 over C equal V over V0 equal F. This implies that F equals C0 over C, 2 over 0.1 equal 20 times. So the solution has been diluted 20 times. Okay, the procedure. Pour in a clean beaker some of the initial solution to avoid any contamination. Take the volume V0 5 ml using a volumetric pipette 5 ml equipped with a pipette filler. Introduce the taken volume V0 in a volumetric flask of volume V equal 100 ml. Add distilled water till the half of the flask and shake. Add distilled water with precaution till the line mark. Close the flask well to homogenize. This procedure must be memorized. Thanks for your attention. Stay safe. Goodbye.